John and Jada presents.
Hello. Hey everybody. My name is John. Welcome to Jada and I, our physics presentation. It's gonna be really fun. We got a whole lot to cover though. We got theoretical equations, we got projects, the whole 9 yards, right? It's gonna be a blast. In fact, speaking of blast, we have our first project here, which was a rocket launch. Now, of course, by all laws of comedy, this should have went horrendously wrong. But as you guys can see, it actually went pretty well. So let's go ahead and get on to it. There we go. Now, I know what you're thinking. John, you suck at recording. I know, but in my defense, it was 2 degrees outside. Filipinos are not built for the cold. However, in order to compensate for you guys, I made this handy little document. Hey everybody, it's Future John. So I found out that Canva is really crappy at editing stuff and it won't let you put a video over 2 pages. So my diagram is a Google slideshow. So as you can see, rocket go up, then rocket goes down. Along with that too, I have to pay a premium on the screen recorder, which means I'm going to screen record the screen recorder. I want it down. I know. John, what was that? Why do you love Czechoslovakia? Well, the latter question is a whole nother discussion. However, the first one is called European street racing. You should check it out. It's pretty cool. Now, I know that so far I've essentially served up a giant nothing burger when it comes to physics. However, hold your horses. We're going to go ahead and talk about that. There is one thing that these 2 videos share in common, okay? They both have gravity. Gravity is the reason why my rocket came back down and why the car didn't shoot off to space. But you might be asking yourself, what is gravity? Well, according to those nerds at Oxford University, gravity is, quote, I can't read that, it's too far away, so I'm going to try to paraphrase here, but it is the force that attracts a body towards another body that has mass. Essentially what they're trying to say is gravity is this post-ironic meme my friend made a while back. I don't chase, I attract. But why does gravity attract? According to most physicists, gravity attracts because of these little particles called gravitrons. These gravitrons are similar to protons or neutrons. However, when they interact with each other, they create the force known as gravity. So any object that has mass, such as you or me, we have gravitrons, we attract. Now, of course, here on Earth, we're too small for this to have any profound effect. But in space, it is the reasons why planets orbit each other, such as the Earth orbiting the Sun. The Sun has a greater gravity, so the Earth revolves around it. And hey, between you and me, the freshman girls must have a lot of gravitrons because they think the whole entire world revolves around them. Along with that too, gravity depends where you go. For example, on the moon, the gravity is much lower than Earth as proved by this equation here. That's because of the moon's lower mass. So that's cool and all, but you might be wondering to yourself, well, this gravity thing's all neat, but why did my rocket not land faster? According to V equals G times T, my rocket should have landed at around the ballpark of 68 to 75 meters a second, or around 165 miles per hour. Well, that leads us to our next topic, called... Alright, to demonstrate air resistance, I'm going to jump out the back of this C-47 cargo plane, so let's go! Currently falling from the air, which means I only have 30 seconds to explain to you what air resistance is. Essentially what air resistance is, it's the opposition of fluid relative to a moving object. As a simplification, that means that I'm crashing into the air particles, which is slowing me down. Along with that too, I'm also traveling at 120 miles per hour, which means I've reached terminal velocity. Terminal velocity is when these forces cancel each other out, meaning there's no acceleration. Along with that too, other factors that are included in air resistance are drag, height, mass, and speed of the object, as well as the density of the fluid!
Oh my god, bro. Oh, hell no, man.
Yo, I do it for my streets, I do it for my hood, I do it for my mom, I do what's good, I do it for...
Along with being professional rocket scientists, John and I are professional ballers, as everyone knows. So today we will be using aspects of projectile motion to teach you how to become baller. I'll do so by showing video examples followed by calculations. You're going. Yeah. To go into further detail about angle, I used two sample problems. In both, velocity is 10 meters per second, and in the first set of calculations, you can see the angle is 20 degrees, but below it, the angle is 45. So I calculated the max height, the air time, and the total distance in each scenario. So for the max height, you find the initial velocity using SOHCAHTOA, and then use that kind of initial velocity to find the time that the max height occurs. You then use the time and the initial vertical velocity to calculate the max height, which for the first scenario to 20 degrees is 0.597 meters. To find the air time, all I needed to do was double the calculated time it took for the max height to occur, which is 0.7 seconds. Then finally, we calculate the initial horizontal velocity using SOHCAHTOA and then multiply it by time to get the calculated distance, which is 6.58 meters. Then, just repeat this process using 45 degrees instead, and then, the calculated horizontal distance that time will be 10.18 meters per second as shown. And this shows that the angle you shoot your hoops has a massive effect on where the ball goes. Okay, so for these calculations, I used two problems again. In both of them, a basketball is being shot at a 45-degree angle. And in the first set of calculations, I used the initial velocity 1 meter per second, just to keep things simple. And then for the second set, I used 10 meters per second. So the calculations are pretty much identical to what I explained before. I'm not going to re-explain it. I mean, I'm just not as interesting as John when I talk. I gotta face reality. I may be a baller, but I'm not very funny. So I'm not gonna sit and explain that. Just for the 1 meter per second scenario, the horizontal distance was 0.1 meter, and for the 10 meter per second scenario, you can imagine it was 10 times greater. The horizontal distance was 10.18 meters per second. So this shows that the speed you pass your basketball or throw your 3-pointers also greatly impact where your basketball goes, which obviously is very, very important for being as baller as me and John. Okay, so now, John and I, we are great at rocket science. We are great ballers, but we have more skills. We are incredible at football. In fact, did you know that John is the quarterback of every NFL team? Every single one of them. Don't believe me? Look at this.